What's up, you freaking geniuses? So in this video, I'm going to teach you how to verify if two functions truly are inverses of one another. Okay, and I'm also going to teach you how to graph them and also how to find their domain and range. All right, so let's start with this first example right here. So it says, verify graphically that the functions f of x is equal to 2x minus 3 and g of x is equal to 1/2 x plus 3 are inverse functions of each other. Okay. So the first thing that we want to do is simply graph these. So let's first graph this guy right here. F of x is equal to 2x minus 3. So it looks like it's just going to be a line, right? And we know that because, well, there's no exponents on this function. So we know it's just going to be a straight line. So in order to graph it, let's just make an xy table, or more specifically an f of x table, right? And we'll plug in some numbers for x and see what pops out for f of x, all right? So let's just plug in some easy numbers. Let's choose -1, 0, 1, 2, and 3. Okay. So first of all, if we plug in a -1 into this function right here, and let's just write it over here so it's a little bit clearer. So here, this is going to be equal to 2 times x, but we're going to plug in a -1, minus 3. So this is equal to -2 minus 3, which is equal to -5. All right. Now, what if we plug in a 0 into the function? All right, so we're going to plug that into x. So here we're going to get 2 times 0 minus 3, and that's equal to 0 minus 3, which is equal to -3. Okay. Now, if we plug in a +1 this time, this is going to be 2 times 1 minus 3, and that's equal to 2 minus 3, which is equal to -1. And if we plug in a 2, we're going to get 2 times 2 minus 3, and that's equal to 4 minus 3, which is equal to 1. And if we lastly plug in a 3, we're going to get 2 times 3, which is 6, and 6 minus 3 is equal to +3. And now before graphing the line, one thing that we need to do is look at the points for our other function right here, g of x, okay? So this time, let's first plot some points right here for this function. G of x is equal to 1/2 x plus 3, okay? So in this case, again, we're just going to make an g of x table. Now, this time, what x values do I want to plug in? Well, the key thing that we need to keep in mind here is that if these two functions that were given, if they truly are inverses of one another, then that means their coordinate points are going to be the exact same. They're just going to be flipped. Okay, so for instance, here we got -1, -5. So then in this other function, we should get -5, -1. All right, here we got 0, -3. So here we should get -3, 0. Right? Same thing over here. 1, -1, so here should be flipped, -1, 1. Here should be 1, 2, and then 3, 3 flipped is still just 3, 3. All right, so again, if these are truly inverses, these are the coordinate points that we should end up with. Okay, so to check all this, what we have to do here is actually plug in these x values into our function and see if these are the y values that actually pop out, okay? So let's start with our first x value, -5, all right? So let's plug in -5 into this function right here. So let's just write it up here. So we have, I can just rewrite it, g of x is equal to 1/2 times x plus 3, right? But we want to first plug in a -5, so we're going to get -5 plus 3. So -5 plus 3 is -2, and half of -2 is -1, okay? Next, we want to plug in a -3 into our function right here for x, right? So let's get rid of that and plug in a -3. So then this time we're going to get -3 plus 3, that's equal to 0, and 0 times 1/2 is just 0, right? Now let's plug in a -1 right there, -1. So then here we're going to get -1 plus 3, and that's equal to +2, and half of 2 is just 1. Right? Now, if we plug in a +1 right here, we're going to get 1 plus 3, which is 4, and half of 4 is 2. Let's write it over here, 2. Okay, and then lastly, if we plug in a 3, plug in a 3 right there, 3 plus 3 is 6, and half of 6 is 3. So as you can see, all of our coordinates match all of these. They're just flipped like they're supposed to, right? So that means that f of x and g of x truly are inverse functions, okay? So if you wanted to, you could even, instead of writing this as g of x for the second function, you could say that this is the inverse function. That the inverse function is equal to 1/2 times x plus 3. All right, great. We know that they're inverse functions, so now let's plot them. So first, let's plot f of x. So let's plot these points right here. So first, we're going to have -1, -5, and that's going to be like down here. And then we're going to have 0, -3, and then 1, -1, and then 2, 1, and then 3, 3. Okay, so if we draw a straight line through all those points, they should connect pretty well. There we go. All right, so there's our first function f of x. Now let's plot g of x, or in other words, the inverse function, right? So here, our first point is -5, -1. So let's see, this is 3, 4, so 5 is about there. So -5, -1 is going to be about there. And then we have -3, 0. And then we have -1, 1. And then we have 1, 2. And then we have the same point, 3, 3. Okay, so if we draw a straight line through these guys, yeah, that's pretty close right there. Okay, so as you can see, it looks like there's some symmetry between these two lines, and the reason for that is because inverse functions are reflected over the line y is equal to x, all right? And this is the line y is equal to x. So this line right here, it runs through the origin and it has a slope of 1. So it goes up 1 over 1, up 1 over 1, up 1 over 1. Okay, and inverse functions are always the exact same distance away from this line right here, y is equal to x. Okay, so for instance, you can see that this point, how far away is it from the purple line? Well, it looks like it's this diagonal, one whole diagonal, and then like half a diagonal, right? All right, what about this point? How far away is it from the purple line? Well, again, you can see that it's a whole diagonal and then half a diagonal, right? Same thing over here. This is one diagonal distance away, and this one's one diagonal distance away, right? And then same thing over here. Okay, great. So now that we graphed these, the last thing that we need to do is find the domain and range. And the way that you find the domain and range is by finding the domain and range of each function individually, all right? So first of all, if we want to find the domain and the range of our first function f of x, again, that's just going to be this linear function right here. And the domain and range of all linear functions is always the same. It's all real numbers, okay? Or another way you could say that is that it goes from -infinity to +infinity. Okay, either one of these work. So that means if we want to find the domain and range of the inverse function, well, it's also going to be all real numbers. All right, let's try one last example here. So this one says, verify graphically that the functions f of x is equal to x squared, and we're restricting our x values to be greater than or equal to 0, and g of x is equal to the square root of x, are inverse functions of each other. Okay, so again, the first thing we want to do is just find some coordinate points, all right? So let's start with this first function, f of x is equal to x squared. And our x values are being restricted to be greater than or equal to 0. So basically positive numbers or 0, right? So here, let's make a table. So we're going to say x and f of x, all right? So our x values, again, they have to be positive or 0. So let's just say 0, 1, 2, 3, and that's probably enough. Now let's plug in these x values into our function and see what we get. So remember, f of x is equal to x squared. So first, if we plug in a 0 right here, 0 squared, well, that's just equal to 0. Next, if we plug in 1 squared, well, that's just equal to 1. If we plug in a 2, 2 squared is equal to 4. And then 3, if we plug in 3 squared, that is 9. Okay, great. So we found a few points for our first function. So now let's find some points for g of x, right? So let's make another x, and then this time g of x table. Now remember, if these two functions truly are inverses, then that means all of these coordinate points are going to be the exact same over here, but just flipped, right? So first of all, 0, 0 flipped, well, that's still just 0, 0. Then 1, 1 flipped is still just 1, 1. And then here 2, 4 flipped is 4, 2. And then here 3, 9 would be 9, 3, okay? So these are the x values that we have to plug into our function, and then we're gonna see if these y values, or g of x values, are the values that truly pop out, okay? So let's delete those right there. And then let's see, g of x again is just going to be equal to the square root of x. All right. So first of all, if we plug in a 0 in here, the square root of 0 is just 0. And then 1, the square root of 1 is just 1. And then 4, the square root of 4 is 2. And then 9, the square root of 9 is 3. All right, so as you can see, we got the same coordinate points over here as we did over here, but they're just flipped, right? So that means that these two functions truly are inverses of each other. Okay, so again, that means if you wanted to, we could rewrite this function as the inverse function is equal to the square root of x. Okay, great. So now that we verified that they're inverses, now let's graph them. So let's graph this one first. So first we have a point at 0, 0, and then 1, 1, and then 2, 4, and then 3, 9 is right there. Okay, so then here you're going to see that this is basically half a parabola, something like that. Okay, so now let's graph g of x, right, or the inverse function. So this one has a point at 0, 0, 1, 1, 4, 2, and 9, 1, 2, 3. Okay, so then we'll play connect the dots with this guy as well. And you can see that this is basically half a parabola also, just kind of sideways. Okay, and lastly, we can draw our line that we're reflecting the functions across. So that's just y is equal to x, right? So this line right here that runs through the origin right there. So again, this is y is equal to x. And as you can see, each of these functions are the exact same distance away from our purple line that we're reflecting across, right? So for instance, this point is one diagonal space away, and this point is also one diagonal space away. Okay, here you can see this is, it looks like 3 spaces away, so then that means this one must also be 3 spaces away. Okay, so it looks like we graphed it correctly, so now let's just find the domain and range of each function. So first of all, let's find the domain and range of our first function, which is x squared. So remember, the domain are basically our side-to-side limits, and our range are our up and down limits. Okay, so just for the function f of x, just this thing in red, the point furthest to the left, you can see, right, as we go along the x-axis, the point furthest to the left right here is at x is equal to 0. So, and it touches that point, right, 0. So we're going to say that the domain goes from 0, and then it's just going to move to the right forever towards the direction of positive infinity. So then the domain goes from 0 to infinity. And the range, you can see it's actually the same thing, right? So as we move up along the y-axis, this is where the range starts, right, at y is equal to 0, and it includes that point, right, because we're touching the origin, so we're going to include that point 0, and then we're just going to head off towards positive infinity in that direction as well. Okay, now we need to find the domain and range of the inverse function. And one cool thing about the relationship between the domain and ranges is that the domain of one function is going to be the range of the other, okay? So if if the domain from f of x is from 0 to infinity, well, the range of the inverse function is going to be from 0 to infinity, okay? And same thing, the range of the function is going to be the domain of the inverse function. So the range, it went also from 0 to infinity, so that means the domain of the inverse function is going to go from 0 to infinity. So if you found the video helpful, make sure to leave a thumbs up down below, and if you have any questions, let me know in the comments section below.